C1 differentiation example 3. We have a function y equals 4x plus 1 all squared. Clearly this is a quadratic function, so it's a curve, and differentiation will help us to find the gradient of the curve. We also need to find the y coordinate when x is 5. So let's first of all find the y coordinate. So when x is 5, to find the y coordinate, we simply need something that says y equals, and here it is. So y is equal to 4 times x. Now remember x is 5, so that's 4 5s plus 1, and then all of that squared. In the bracket we've got multiplication and we've got addition. We have to do the multiplication first. 4 5s are 20, plus 1 is 21, and then we need to square 21. Well, 10 21s are 210, and then another 10 21s will be another 210, so that'll be 20 lots of 21. I just need one more 21 to end up with 441. So the y coordinate when x is 5 is 441. Now let's find the gradient. And like I said before, this is a curve. So differentiation helps us to find the gradient of a curve. Unfortunately, it's not currently in the form y equals kx to the power n. It has brackets. We need to get rid of them. So let's expand those brackets. And we have 16x squared plus 4x, and then we'll have another plus 4x. So that's plus 8x plus 1. Now it's ready to be differentiated. We have 3 separate terms, and each of them is actually in this format. In the last one, technically it would have a power of 0 for the x term, which is why we don't see it. So now we're ready to differentiate. Let's do so. dy by dx. So we can do the same thing 3 times. Multiply by the power of x, and then subtract 1 from the power of x. So that's the first one done. Again here, we have an invisible power of 1. So multiply by the power, and then subtract 1 from the power. That would give me x to the power 0, which is 1. So therefore, I'm not going to bother writing it, because 8 times 1 is just 8, obviously. Here we have a constant on its own, and when you differentiate a constant, it just disappears. It differentiates to 0. So I could write plus 0, but there's no point. Right, we've differentiated. Now let's find the gradient when x is 5. So when x is 5, the gradient will be 32 times 5 plus 8. Once again, we have multiplication and addition, and BIDMAS or BODMAS or any word to that effect reminds us we need to do multiplication before we do addition. So 32 times 5. Multiplying by 5 is actually quite easy. Simply multiply by 10 and then halve your answer. So 32 times 10 is 320, and then halve it. So you get 160. 160 plus 8 is 168. Just a quick note regarding dy by dx. Don't think that 32x plus 8 can be simplified to 4x plus 1. It can't. 4x plus 1 is 8 times smaller than 32x plus 8. These numbers here have a common factor of 8. They do have a common factor of 8, but we can't go dividing it by 8, because that'll make it smaller. We've changed it, so that's no good. The only thing you could do is factorize out a common factor of 8, but there's no point in doing that. So if we put 8 brackets 4x plus 1, that is still equal to 32x plus 8, so that's okay. But again, there's no point in doing this, because we're simply going to sub in x is 5, and that's the end of the question.